Hello, this is public lecture 2. It's going to be over the science of origami public lecture. So the main idea of this was that we are able to study origami, and looking at origami through a perspective of math and physics, you can design structures that can carry more weight and be more stable, which is applicable to real-world designs in engineering. So some of the main points is origami. It's very versatile. It can hold large amounts of weight if you fold it correctly, and it's collapsible and also light. And shape and the folding of origami, it plays a very important role in the strength of a structure. Depending on how you fold it, a structure can be stronger or weaker. Similar to how you design bridges, for example, and how many supports you put on it. Thicker material is typically harder to fold, and as you fold something and you repeatedly fold it and make it thicker, that also will make it harder to fold. So a paper that has been folded over 5 times is going to be harder to fold than a paper that's been folded over twice. And real-world applications of it is that with origami, you can use it to reduce volume if it's needed to be stored in an area, and then if you expand it outwards, it can be used to maximize the surface area. So it's quite good for storage. And then finally, understanding the science behind folding. You can design decorative origami like flowers or birds or bees or bunnies, but then you can also use it in a practical standpoint of designing things like bridges. Some new facts that I learned about origami that I did not know about was that origami is believed to have originated from China. However, it is very popular in Japan, and the rest of the world now use it mostly for their own purposes. Some things I did not know that they used the idea of origami behind was flexible solar panels to extend the volume and surface area needed. This specifically was when they were trying to put solar panels into space because they needed the energy. But there was not enough room for them, so the idea was to fold them like origami to reduce the amount of volume that would be needed in storing them, and then once you got out into space, you could release them, and it would increase the surface area of the available panels. It didn't work, it ended up getting stuck, but the idea behind it was correct. And in future ones, I believe that they tried to expand on the idea and make it where it would fold out by itself. I also learned about Macquarie's theorem and Kowalski's theorem. Both of these are about folding and knowing whether or not that something is foldable. Kowalski's theorem is that with the valleys and the mountains of fold, so like the ups and downs, like the zigzags, if you count them, there's always going to be a difference of 2 between them. And then Kowalski's theorem is that something's only foldable if the angles between the every other folds can add up to 180 degrees. And then some possible expansions. I wasn't too sure what to put for like possible expansions. However, I did wonder if with origami being a lightweight structure that if you can fold it apparently the correct way is able to distribute weight enough to where it'll be able to hold significant amount of weight. If you could use origami ideas in a like flexible or foldable plastic material to make collapsible pieces of furniture, such as like beds or couches or tables that you could quickly set up and then deconstruct, that would be very lightweight and easy to move around if you were like in areas like such as, I don't know, like camping or places that you had to move quickly in.